complex and its participating units. Ladies and gentlemen, good morning to you all. I welcome you all on this occasion of National Science Day. National Science Day is celebrated in India every year on 28th February. This year, this day commemorates the invention of the Raman effect by the great Indian physicist Sir Chandrasekhara Venkata Raman. It was on this same day that Sir Raman made to the world his greatest invention, the Raman effect, in the year 1928. He was awarded and honored in the year 1930 with the Nobel Prize in the Physics for his great success in the field of science in India. In 1986, Government of India announced 28th February as National Science Day. On this day, we show our dignity and respect to the famous Indian physicist to mark his discovery of the Raman effect. Sir C.V. Raman was born on 7th of November 1888 at Tiruchirappalli, Tamil Nadu. His father was a lecturer in physics and mathematics. Raman was the first person to research such an invention in India. He worked from 1907 to 1933 in Kolkata at the Indian
Director ma'am, your mic is muted, ma'am.
Yes. Okay. Now we just check it.
His discovery marked a notable achievement in the Indian history. The main objectives of celebrating this National Science Day is to bring awareness to people about the importance of scientific applications in their daily life and to encourage them by popularizing science and technology. It allows the scientists and experts from the field to discuss issues and new technologies trending in the field. Dr. APJ Abdul Kalam mentions science is a beautiful gift to humanity. We should not distort it. Science helps us to understand the origins, characteristics, and consequences of global problems. Finding solutions to these problems and elucidate the complex chain of cause and effect through which they may be linked required an integrated approach with the participation of natural and social scientists, engineers, and policymakers. As science plays an ever increasing role, however, scientists must remain true to the fundamental principles of objectivity and impartiality. In some cases, research and monitoring programs offer the warning to government officials and to the public of an emerging problem. Science is critical to tackle complex challenges for humanity, such as climate change, biodiversity loss, pollution, and poverty reduction, as it lays the foundation for new approaches and solutions. Transforming scientific breakthroughs into new technologies can have a profound impact on development. One challenge of sustainable development is to use technology in such a way that it balances advances in productivity with long-term resource viability. This is a critical role for sustainability science as it promotes cross-disciplinary approaches to advance the understanding of human environment, interactions and systems, and how these interactions affect the challenge of sustainability. UNESCO's Assistant Director General for the Natural Sciences highlights that sustainability science is an issue of a normative nature. It is an approach which will allow to capitalize on research as a tool to solve problems. The theme of National Science Day of 2022 is Integrated Approach in Science and Technology for Sustainable Future. Minister of State for Science and Technology, Dr. Csir-Cmc, said every year the theme is conceived keeping in consideration the immense immediate priorities of the nation, of the society, and the world as a whole. Today, India is also increasingly assuming a global role, and as Honorable Prime Minister has been reiterating at every available forum that we have to come out of the culture of working in silos. Now, to come out of silos is no longer a matter of only opinion or by choice. It is a necessity. Today, indeed, we are very fortunate to have Professor Kamakoti, Director, Indian Institute of Technology, Madras, with us to celebrate this year's National Science Day. I thank him for accepting our invitation amidst its busy schedule. He has designed India's first indigenously developed microprocessor, Shakti. His deep expertise in computing and cybersecurity is well known. Professor Kamakoti was faculty in Department of Computer Science and Engineering before taking up this role and led the research team that has designed and booted up Shakti and can be used in mobile computing devices and networking systems. Professor Kamakoti was the chairman of a task force on leveraging artificial intelligence for development across various fields. I welcome you, Professor. I once again welcome you all and conclude with a Tirukural, Epporul Ettanmayadayinum, Apporul Meipporul Kanbadarivudu, which means that analyzing the information, understanding the meaning, and accepting the fact will help one to gain profound knowledge. Hence, true knowledge is the ability to understand the truth behind people, things, and event. Thank you. Over to you, Ramya.
Thank you, ma'am. I now request Dr. Bharat Kumar to introduce the chief guest of today's event.
Good morning and welcome to all the participants to the National Science Day function virtually. I feel extremely honored to introduce the chief guest, Professor B. Kamakoti, Director, IIT Madras. Professor B. Kamakoti received his MS and PhD degree in Computer Science and Engineering from IIT Madras. He joined as a faculty of IIT Madras in 2001 and took over as a director in January 2022. He specializes in area of computer architecture, information security, and VLSI design. He heads the microprocessor development program and information security education and awareness program at IIT Madras, funded by Ministry of Electronics and Information Technology, Government of India. He is a member of National Security Advisory Board. He was the chairman of Artificial Intelligence Task Force constituted by Ministry of Commerce and Industry, Government of India. At IIT Madras, he has served as chairman JEE and as associate dean, industrial consultancy and sponsored research. He has over 150 publications in international journals and computer conferences. He has guided many research scholars for their PhD and Master of Science by Research program. He has coordinated and successfully delivered close to 50 projects from industry and government R&D establishment. He serves in Technology Committee of the National Stock Exchange and Reserve Bank of India. Dr. Kamakoti is the recipient of many awards. Few notable are DRDO Academic Excellence Award 2030 for his outstanding contribution over several decades in the field of scientific research and technology development. ACCS CDAC Foundation Award for 2018 for his contribution in the field of VLSI design and computer architecture, resulting in development of India's first RISC fifth family processor. Indian Electronics and Semiconductor Association Techno Visionary Award 2019 acknowledgement of his path-breaking contribution in electronics and semiconductor domain through academic and research. The IBM Faculty Award 2016, which is a competitive worldwide program intended to foster collaboration between researchers at leading universities worldwide and those in IBM Research, Development and Service Organization, and also Vasvik Industrial Research Award. With this brief introduction, I kindly request Dr. V. Kamakoti, Director, IIT Madras, to deliver National Science Day lecture on data science, artificial intelligence, IoTs, and cyber physical systems. Thank you. Over to Professor.
Thank you very much, and a very good morning to all of you. I think can you just mute the mic in Director's office? Mute your mic. I think that's a feedback. Yeah. Thank you very much for inviting me, and it's a pleasure. I've been working very closely with the Csir-Serc Chennai through the Civil Engineering Department. We had a lot of interactions. And long back, around 5 to 6 years before, we had been talking about cyber physical systems, data science, IoT, and whatever the topic that we had mentioned today. At least 6 years before, we had started some projects, and we had actually ventured into it. So let me very briefly. So how much time do I have?
So 30 to 45 minutes, you can take your time, sir.
Yeah, I'll take 30 minutes. I'll take 30 minutes and we'll have some interactions. Today, with the advent of the digital world, Very importantly, after the COVID, where people have started working and interacting digitally like how we are doing now. One of the consequences of this digital world is basically the amount of data that we create. Anything and everything that we do digitally amounts to some sort of a data. It can be speech, it can be video, it can be sensors that give you digital data. It can be on an Excel file. Ultimately, we create a lot of data. Data has been proven to be both statistically, empirically, analytically proven to be a good indicator of what has happened, what is currently happening, and what could potentially happen. Both the past, present, and future can be predicted with a lot more confidence through data. Data is basically used to validate the analytical models. Now, this is the basic situation. And now world has realized, not only the researchers, but a lot more industry have come up and they have started accumulating data of all formats. And this could potentially lead to multiple judgments or decisions that we can take of what is happening today and what can potentially happen tomorrow. And data will form a major ingredient for decision making, so that for any field, whatever best that the field could offer, those decisions which can make the best from that field could be taken based on whatever data is accumulated. So this is the scenario today. And that leads to what we call as the cyber physical systems. Now, what is a cyber physical system? Let me take a very interesting example of a cyber physical system that we did, that the government of India launched for the benefit of controlling COVID. The system is Arogya Setu. Many of you might have used it. Now, what did Arogya Setu do? So when we look at a cyber physical system, there are three important components in that. Component number one is a field level sensing mechanism, which will sense whatever you want. There may be a requirement for a particular problem and you sense that. Then there is an intermediate level which accumulates this sense data, do some sort of processing, retain some information, discard some information, do something at the edge, and then finally there is a cloud which actually collects all these data and makes some crucial decisions. So when we look at the cyber physical system, there are three parts, namely the field level, the intermediary level, and the cloud level. Now, when we look at all these three, now let us look at Arogya Setu and let us see what is the field level there, what is the intermediary level there, and what is the final, the cloud level. So let us look at this example and get to an understanding. And as a good example of a cyber physical system. Now, what is the requirement in the case of Arogya Setu? We really want to find out if a person who has tested positive for COVID, was he or she close to some other set of people? And if they were close to some set of people, we need to find out and warn those people. This is a very simple requirement. So how did we manage this? When the field level sensing mechanism, I mentioned there should be a sensor. The sensor in this case is basically a Bluetooth sensor. So every mobile phone has a Bluetooth. Now, what does the Bluetooth sensing mechanism do? Every phone has a Bluetooth, and when A and B, person A and person B have installed Arogya Setu in their mobile phone, the Bluetooth sensor in their respective mobile phone will communicate with each other. And based on the strength of the signal, one can go and find out how close they were and how much time they were at that distance. So when A and B who have installed ROK Setu come in close proximity to each other, the Bluetooth basically communicates and basically records how close they were and how much time they were in that same distance. And this is recorded. So A's information, A's mobile ID is recorded in B and B's mobile ID is recorded in A. Right? Now, so the mobile, which is the intermediary device, stores the information. The mobile of A stores the information that B has been in close proximity for this much time. And similarly, B's mobile stores the mobile ID of A along with the information that they are close for this much amount of time. And this is stored. And when A, this is stored in the intermediary level. This is not sent to the cloud. And when A or B test positive, let us assume A test positive. Now, all the details in the mobile phone of A is taken to the cloud. And in the mobile phone of A, there is the detail that B has been close to it, him or her. And so the cloud will now know that B is possibly can be affected by this. And then the cloud will send a warning message to B saying that you are in close touch with some person who has tested positive. It will not reveal the identity. And then say that you go and test yourself. And if you are positive, please take the necessary care. Now, in this entire process, please note that there is a sensor, which is Bluetooth. There is an intermediary device, which is the mobile phone. And there is a cloud, which takes care of coordinating this entire activity and making certain decisions. So this is how a cyber physical system is formed. So they are an excellent example of a cyber physical system. There was a team which actually I was also part of the team, which the whole software was brought up in 21 days. And more than 19 crore people have been using it till date. So this is a big example for the country that we could come out with such very, very interesting, very phenomenally scalable software or mobile app. Now, when we conceive such a system, there are many challenges that we face. The first challenge is about the privacy and security. Any cyber physical system today, there is a data that is being generated, and this data need to be carefully evaluated for the privacy and the security needs. Now, that is precisely the reason when we look at ROK Setu as an example, we had not, when A and B come close to each other, A's mobile number is not stored in B. A's mobile ID is stored in B. Similarly, B's mobile number is not stored in A. B's mobile ID is stored in B. The ID to mobile number map is very unique and it is known only to the cloud. So A cannot find out if he gets infected, it is because of B. Then there will be a social commotion there. Right? So that's very, very important. And similarly, if B gets infected and he will not know why because of A, he'll know because of someone and he cannot find out who that is. And that is very, very important in this context because otherwise there can be a social problem. Right? So privacy and security essentially becomes extremely crucial when we start addressing these cyber physical systems. Now, this is one point of the view, but the more important point is as these cyber physical systems come close and close to ours, it becomes part of our day-to-day living. It also becomes important that there is a need for security. Now, we need to be protected. These systems should not come and leak data about us, should not leak data about any of our things that could be of potential danger to our business or life or whatever our living. And that is where the Atmanirbharta or the indigenous efforts, which our Honorable Prime Minister has been advocating for quite some time, probably in the midst of the COVID, the word Atmanirbharta was coined, and I think it's very apt at that point, and that is very, very important for us. Today, when we look at the entire spectrum of all these, systems that are developed, please let us understand that all these systems are programmable. These systems have a microprocessor inside it, and this microprocessor is programmable. And when you program that microprocessor, you can actually make it do something that is not desirable also. It is not that the person who manufactures the device puts these malicious code, but they would have put some code which has certain vulnerabilities which could be exploited by the hackers who can come in and change it. Right. So this is the most important thing that we need to take care of when we start building these systems in large scale. Now, at that point, it is quite unadvisable for us to have a programmable element in each one of these cyber physical system at each place of the cyber physical system. That is a black box. So that is why the India Microprocessor Development Program was announced by the Ministry of Electronics and Information Technology, wherein IIT Madras also participated through its Shakti offering. CDAC is participating through their Vega offering. Vega is a class of microprocessor that they are doing for the country. Shakti is also a class of microprocessor that we are doing from IIT Madras. And IIT Bombay is doing what we call as the Ajit series of microprocessors. And what we are looking at these microprocessor program is not just some device, one device that will be put, but a family of microprocessors that can fit on to all these requirements. For example, at the field level, you need some microprocessor. At the intermediary level, you need some microprocessor. And at the cloud level, we need a microprocessor. So for all these three, we need a family of microprocessor. For example, the type of microprocessor that we'll put at the field level will be a very short, tiny one, which needs to just accumulate data. What you put at an intermediary level would be something which will not only take this, do some computation, store data, probably handle a database, and then communicate. So that will be a little more or a significantly more complex microprocessor. And what you put on the cloud will be a parallel computing microprocessor, like a multi-core, highly large-scale multi-core microprocessor. So we need a family of microprocessors to essentially evolve a Atmanirbhar self-sufficient system here. And that is also very, very important at this point of view. And one of the other things that we have been advocating is that the person who develops the microprocessor and the software that is executing should not be coupled. If a company A is producing the microprocessor, the same company should not write the software. The software should be written by a completely independent entity, or the software should be open source and should be controlled by government or by an open source community. So by doing this, by decoupling the hardware and software and making the hardware like a commodity one and the software being written and put on top of it, we can ensure a lot more of security that we want to perceive. Right. So this is one state today. And the moment we say that we want our own microprocessor that should be manufactured, then comes the important thing that we need fabrication unit in the country to manufacture such microprocessors. And that is where the current microprocessor semiconductor policy of the government of India, again announced by the Ministry of Electronics and Information Technology, comes in a very big way. $10 billion had been announced for this. And we hope that there'll be a fabrication unit at the earliest point of time, which will basically push the Atmanirbharta effort of the government in a very big way. Now, so these are all some of the building blocks, and this is what we are headed today. And there are government policies which are basically trying to help. I'm trying to put the different policies into one nutshell and tell you how this will evolve as a single large picture for a very, very for the next 5 years vision for our country. Now, another basic building block here, the most important building block, is the communication. I collect data, but I need to communicate to a cloud. Communication becomes extremely important. And it can't be wired communication, it needs to be wireless communication. And that is where high bandwidth communication becomes extremely important. Now, today, we may say that 60 to 70% of our country is currently covered very well by 4G. But there's still a large amount of packets, still they don't have access to good 4G. 4G will be there, but not the real speed that we are looking for. There are still aspirational districts and rural districts which are still not fully covered by a wireless mobile network. And that becomes extremely important when we are trying to build in such type of cyber physical systems. Now, in this context, 5G comes very, very important. 5G is not 4G, high-speed 4G. It's not 4G plus. 5G is not something that you are trying to say that I will see a high-definition video, right? Instead of a normal video of a movie. It is not entertainment plus. Yes, it can be used for entertainment, but 5G is going to be the basic building block for Industry 4.0. 5G is going to be an economic turning point, right? So what is 5G? It gives you, it is expected to give you at least 5 to 10 times the speed of 4G. That means you need lot more hardware, lot more coverage, lot more of things to basically regulate this traffic and bring it. So in this context, I am very, very proud to announce that to tell you all, many of you would be knowing this, that India, through a consortium of many institutions, including IIT Madras, have now currently successfully built a protocol called 5G India. And this has been accepted by the International Telecommunication Union and the third generation project partnership, the 3GPP. What does it mean? Today, when there is a device, there is something called a base station or your tower. If you look at 4G, there is a tower. And there is a coverage which this tower can offer. In the case of 5G, a particular base station, if it can offer a distance of X, the 5Gi today has the potential to offer a distance of 2X. Correct? And that is the power of the 5Gi. It has a very, very, very new, more novel, brilliant, I should say, encoding scheme, which basically gives you this extended coverage. And this is very important for a country like India. Number one, if I could get an extended coverage, I can reach more places that I cannot reach because of, we have mountains, we have plateaus, we have plains, we have all in the country. And I can start reaching places which otherwise would not have been accessible. Number one. Number two, the number of base stations I need to deploy also reduces, essentially bringing down the overall power requirement for the country. It now becomes a sort of a more green type of a 5G requirement, and this will go in a large way for us to meet some of our carbon commitments of carbon emission. I think that is something extremely important for the country. And more importantly, this is a standard essential patent. In my career of around 35 years, this is the first time I see something like this happening from India as an Indian standard being pushed at the largest technical forum of telecommunication. And this has happened this year, and our 75th year of independence, as we celebrate our Amrit Mahotsav, I think this is very, very important for our country. So this is something which is the basic building block, and that has given us quite a good impetus for the cyber physical systems. Coming to place like Csir-Cmc, where cyber physical systems come up. So we did a project for railways where we put a sensor, an accelerometer, and a strain gauge on a steel bridge and try to find out when a train moves, what is the acceleration and the strain, and to find out if there is a deterioration in the quality of the bridge. Now, initially we started off with a very fancy device, which we imported for $30,000 and put it in a bridge somewhere in Nagari, the outskirts of Tamil Nadu Andhra border. And then first one train went and there was some data that we were seeing at IIT Madras. When the next train went, there was no data. So we went and opened that that enclosure, and there was fire. Where we realized in Indian Railways the ground, the supply is on the top, and the ground is actually the track. And when a brake was applied, there was some EMF generated, and there was no surge protector in this, and it went and burned the entire device. And no, the company which came and installed, the multinational company, did not even know about this. And so we had to send it back to foreign country for reservicing that. At that point of time, we started developing a small Lego type toy, Lego toy type of thing, where we had an accelerator board, we had a processor board, we had a sensor board, we had a power board, and we just plug and play these things. And then we made this design, and we put it in an enclosure, connected the strain gauge and the accelerometer, and again put it on the Nagari bridge. And then we had a Zener diode, which we put as for surge protection, which was 1 rupee, and connected, and the whole thing worked. It worked for 1 week. We got all the data, and we went and removed a simple, a AA, AAA battery, and this all worked. And the cost of this entire thing with enclosure was coming to some 1,200 rupees. Right? So that is where we got the confidence. The project that we worked with railways and under some program of Government of India. This gave us a confidence that we can make devices that suits our country, our country's need. Our country has an environment. We have a DNA. Now, that was something that was a very interesting project that I was also personally involved with my colleague, Professor Saravanan from Civil, and we did this work. A similar type of effort, I know at the time I was also interacting with Csir-Cmc, was happening on the road. This was on a bridge on a railway. Similarly, roads on the highway, there was some similar efforts that have happened. And I think that is where we felt that, when we start designing things for our country, suiting our country's need, rather than bringing a device from abroad and making our country need suit that device, this vice versa was much better. And so that was a very interesting project, which again, that time was the cyber physical system, because we were collecting the data on the device and communicating to a local desktop machine on the track, railway track, which will collect this data. And from there, it actually used a 3G communication at that point of time to send it to the cloud server, which was situated in IIT Madras. So the same field level, intermediary level, and cloud level was there. In the cloud level, we actually plotted the acceleration and the strain plots to find out how stable the bridge were. So this was a project which was very exciting. The entire way I was teaching embedded systems and computer architecture at that time, after this project, I realized that whatever I was talking before was totally theoretical and useless. So I really I changed the way by which I need to teach such courses, right? So these are some very interesting things that happen once you start developing systems end to end for the country. for the country's need. And that is where we also get a field level, ground level experience. And that takes us to a large way. So to conclude, as a country, we are now opened up. We have a semiconductor policy. We have a lot of needs of cyber physical systems. And very importantly, this need to be interdisciplinary. It is not that one computer science professor or one civil engineering professor can work in silos and get it. When you take ROK Setu, we had electronic engineers, we had software developers, we had legal experts, we had virologists, right? And we had large-scale database architects. So it was not just one; it was an entire community of people coming from various walks of life who joined together to make the system. So interdisciplinary becomes extremely important. So I also want to conclude this by saying that the government of India under the Department of Science and Technology has aptly got one program running, one national mission running, which is called the National Mission on Interdisciplinary Cyber Physical Systems, NMICPS. 26 technology innovation hubs have been established across the country. There is a technology innovation hub working on sensors, networking, actuators, and control systems at IIT Madras. It's called IIT-M Pravartak Technologies Foundation. And we have this major effort that is going on, concentrating on different aspects of cyber physical systems. I also invite Csir-Cmc to basically be a part of this national mission, wherein we can take some collective projects, joint projects of interest, and build systems that would be of great Atmanirbharta and a great contribution to the societal problems of importance today. With this, again, I thank you very much for inviting me to deliver this lecture on this very important day, the Science Day. And I hope I had conveyed something which is interesting to all of you. And I look forward, I invite you as a director of IIT Madras, I invite you to be more. I'm sure Csir-Cmc and IITM are working on multiple projects. I take this opportunity to strengthen this to the next level. Thank you very much, Director, and all of you.
Thank you, sir.
Professor. Thank you, Professor. And you have given a practical example of how cyber physical system, which is in need of the hour, and how it was successful through integrated approach. So I think we will also participate in the, we'll look forward for more interaction, collaborations in the near future. Thank you, Professor, for accepting our invitation. Over to you, Ramya.
Thank you, sir. We are indeed honored to have listened to your lecture on elaborating us on the importance of data, different components of cyber physical system, and also highlighting us on some of the challenges faced by such system. Thank you, sir. I now request Dr. Satish Kumar to deliver the vote of thanks.
A warm and cherished morning to our most valued Honorable Chief Guest, Professor V. Kamakoti, Director, IIT Madras, respected Director, Csir-Serc, and the Coordinating Director, Csr-Cmc, Dr. N. Ananthavalli, and my dear colleagues. It's my privilege to propose a vote of thanks and acknowledge the contribution of those who worked hard to make this National Day's function a grand success. On behalf of Director and my own colleagues, I give a really heartfelt vote of thanks to our Chief Guest, Professor V. Kamakoti, who spent his busiest time in gracing the occasion and to deliver the National Science Day lecture. Thank you, sir. Today, we had the opportunity to hear your lecture on data science, artificial intelligence, IoTs, and cyber physical systems. And your lecture has enlightened our young minds and shown us a new path. I sincerely thank our Venerable Director, Dr. N. Ananthavalli, for her valuable guidance and support in organizing this National Science Day function in a grand manner. With a deep sense of appreciation, I thank Dr. Bharat Kumar, Advisor Management, for the valuable support in planning and coordinating the entire event. This type of function cannot happen overnight. It requires planning and bird's eye for detailing. We have been fortunate to be supported by a team of very active and dedicated staff from BKMD, TCC, ICT, KRD, and Director Secretariat who are well versed in their jobs. I lack words for their participation and their willingness to complete tasks beyond their comfort zones. My sincere thanks and deep appreciation go to the people who worked behind the scene for the successful conduct of this event, our staff from administration, purchase, and accounts. I personally thank and Ramya for comparing and Vijayalakshmi for event capturing of the National Science Day celebration. If I have missed out someone who have contributed directly or indirectly for the successful conductance of this function, it's not intentional, for which I may be excused. Once again, thank you everyone. Jai Hind.
Thank you, sir. I once again thank our Chief Guest, Professor Kamakoti, for joining us today, and all the staff members of CSIR, SCRC, and CSIR Madras Complex for making this event a grand success. Thank you all.
Thank you, Professor.